the Flash video tutorial. Thank you, Rhonda. That was Rhonda with our hit new song, Flash Video Tutorial. Welcome to For Loops Part 2. We're going to get a little more complicated here. This part of a for loop isn't necessarily the most important thing for simple tasks, but if you want to do something maybe a little more complex when you're checking values and specific variables, this is going to help you out a lot. So, new ActionScript 3.0 documents. I'm going to save this as my name. Once again, you should use yours on your H drive. Mr. Davis dash for loops part 2. So now that that is done, let's go ahead and create a layer. Well, it's already created. Let's just call it actions. And once we have that done, F9, bring up our beautiful actions window. Now, once we have that done, let's knock out some things really quick. Let's just say for loop structure at the top here, just so we remember what's going on. Remember, we have for keyword, the initializer, a test, and a counter. Okay, and then we have our curly brackets. Okay, let's create a variable really quick, I, because remember, if we're going to use this in multiple places, we probably want to keep this at the top so it doesn't give us that duplicate variable name error. So we have var I, so we'll use our for keyword, and we'll just make a loop from 0 to 10. So we'll say var, now we already did that, so I equals 0, so we're going to start at 0, as long as I is less than 10, so we'll go up to 10, including 10, no, sorry, up to 10, less than 10 would mean we get 9. So let's do this, let's say less than 11, so let's count, okay, sorry, we'll go from 1 to 10, so when I is equal to 1, less than 11, then the counter is, oops, I plus plus, oh my god, parentheses, curly brackets. So an initializer is I equals 1, we're going to do this as long as I is less than 11, and then each time we're going to add 1 to I. So let's just trace out whatever I is. So like we've done before, this is just another way of doing it. We're going to count out 1 to 10, as you can see up here, right? Pretty straightforward. But now let's say you wanted to exit this loop for some crazy reason and actually break out of the loop, essentially stop running the loop. Well, there is a keyword called break, and let's put this here, keyword break to exit a for loop. And what this does is if we put the word break here, which I want to do this as well, and actually let's put quotes around this so we know that it's just this word break. Let's put break here and then a semicolon, and what this is going to do is when we start the very first time, it's going to hit break, stop doing this for loop, and then continue on at line 12. So nothing will actually get traced out. So if I put the break there, it says nothing. If I put the break after trace I, it'll trace out the first one and then break. So only do one, no matter what I set with these numbers. So we can break to exit a for loop, which will completely stop it. But let's make this a little more complicated. We're going to trace out I, and then if I equals 5, okay, so at 5, then we're going to break out of this, okay? So what this should do is trace out 1, 2, 3, 4, and 5 because the trace is before this, and then break out. Okay, so what this is going to do is say 1, 2, 3, 4, 5, bam, then it's done. Cool. That's how that works. Pretty straightforward. I hope that makes sense. If not, ask me questions. But if not, let's copy this whole line here and paste it on 17. Instead of keyword break, we want to say keyword continue. So here's another option that you can work with. Say continue to skip one count of skip one count of the loop. Or I guess skip one count of the loop, or continue to go to next count, I guess, or number, or next increment. Let's get rid of all this here. So I'm going to cut this, Control X to cut. I'm going to paste this down here. Okay, so what continue does is essentially once it hits continue, it skips the rest of the line. So in this case, it'd be the trace, and then it just goes to the next I guess, the next I++ in this case. So to better illustrate, because sometimes it's easier to show than to actually explain. Before we do this here, I'm just going to show you this. So leave this like this. For now, I'm going to put a continue up here just so you can see what happens. So if we put a continue at the top, what's going to happen is, remember, this is from our first break, okay? When we put continue, it's skipping every single thing below it, and it's never actually tracing out. So before we go anywhere else, right before we break, let's trace out a break so that we know where that break actually happened. So we're going to say trace break happened here. Let's do that. Okay. So now we're going to say the break happened here. There we go. And after that, let's put a little trace. So we're just doing some aesthetic type stuff. So I'm just going to trace out a dashed line so that way it'll say break happened here. And then we know when the continue part starts. Okay. So that's just for visual effects. So back to business. We put continue right here. When you put continue, it skips to the next iteration, the next count. And the difference between putting that at the top and break at the top is break will run the one time, it hits the break, and then it stops running the loop completely. Continue will keep continuing until I is greater than or equal to 11 in this case. So what's going to happen here is if I is equal to 5, let's trace out continue happened here. Okay. And what should happen is we're going to skip 5 and we're going to go to 6. So instead of 5, we're going to get continue happened here, and that's it. So now, we have 1, 2, 3, 4. Continue happened here. 6, 7, 8, 9, 10. A more real world situation where this would be applicable is, let's say you have a bunch of enemies you're looping through and you want to move them around, or do something along those lines. But we don't want to move any enemies that are paralyzed. Let's say they have the trait that they're paralyzed. Well, we can check to see if they're paralyzed. And if they're paralyzed, we just say continue, and then we wouldn't move them. But let's do something cool and actually visual besides stuff in the output. Because the output's nice, you can understand it, but it's not so pretty, I guess. So let's do something that maybe we'll find a little fancy. We're going to... Well, let's start from scratch, okay? So right here, we're going to say, let's create a variable. So we'll say var, what do we want to call it? I? We can keep I. We need another variable. We want to say var test. Let's call it test. And it will be an integer, and we'll go from there. So we'll say for I equals 0. Okay, I is less than test, I plus plus. All right, and right now this isn't going to do anything, but I'll explain more in just a second. So we have the initializer, the test, and then the counter. Okay, so what we need to do now is we need to create some kind of object. So I'm going to go with a rectangle, or not a rectangle, I guess a square. And please make sure this is a square when you do this so that I understand that yours will match up with mine. So I'm going to make a red square. Doesn't matter what the stroke is. Just click, hold shift. So it's a square. There we go. I have this. So now what we want to do is tap F8. Make sure your registration point is in the center. And we want to name our... Do we want it in the center? Yeah, whatever. We might have to play around with this, but we're going to give it a name. Just call it RS for red square, and we want to export for ActionScript. So make sure you drop down this advanced tab, export for ActionScript. The class is RS. It's a movie clip, and then go ahead and click OK. And once we have that, we can delete this out of here. And now we can access it from our library with the words RS. So what we're going to do really quick is make a variable var. We'll call it red square. Okay, it's going to be type RS like we just made. Oops, and make sure it actually says RS and it doesn't autocorrect it, and it will equal a new RS. Same thing, mine keeps autocorrecting, so make sure it says rs. Okay, so once we have that, we can pull width, length, stuff like that. And we're going to pull the width of rs. And what we're going to do is set test equal to it. So what we're going to say is test, integer, is equal to, and we want to round, so we're going to say math dot, actually we want a floor, yeah, so we're going to floor. So what we're going to do is say, from the red square, we're going to see how many times it can fit from the left to the right of our stage. Okay, so meaning how many times can it fit in the width of the stage. So what we're going to do is take stage dot stage width and put that inside of math.floor divided by red square, because we need the variable name square, which is this part here, dot width, and that should get us how many times that should happen. So let's trace out test really quick, and let's do the math in our head for just 1 second. So test, we have, just so we can make sure this is going on correctly. So in RS, double click on it. Mine is, what's with 80, okay? It's gonna bring up a calculator. So 80, and the size is 550. So I'm gonna say 550 divided by 80. So it should go into it 6.875 times. And if we round this down, we should get the number 6, because it can fit 6 times completely. So if I run this, let's make sure that my math matched up. You'll have different numbers, so just make sure your number matches up. And you can see we get 6 at the end. So that math is correct. We've checked that with the calculator. So save. So what do we actually need to do with this? Well, for I equals 0 to I is less than test, that's meaning it'll go 0, 1, 2, 3, 4, 5. So that's 6 numbers total because it's including 0. We're going to do something. Well, let's actually take red square, since we already have the variable. We'll set it equal to a new rs, so we're getting a new one every time. So we're just reusing this variable we had from up here, okay? And then we want to add it to the stage. But before we do that, let's put some comments on here. So pull from library. I say pull rs from library, okay? And then test how many times we can fit rs in the stage. So normally it'd be better to put some kind of other variable, but or name, we're just using test for now. So we're going to take red square equals a new rs, and then we're going to add child red square. And this isn't quite going to do what you think it might, but it will add red square to our stage. And notice how there's nothing on our stage right now. So it should pull red square from the library and make 6 copies of it. And now there's only one, and it's in the top corner. So that kind of seems to be a problem, right? Well, the problem with that is that they're all being thrown right now on top of each other. So how can we fix this? We can actually change where red square is located. So let's type red square dot x, okay? And we'll set it equal to whatever I is, so 0, 1, 2, 3, 4, 5. And we need to space it out. So we'll say I times however wide red square is. So red square dot width. So when we have that, what should happen is we'll move each instance of red square to be right next to where the last one is, essentially. So let's double check this, make sure it works. And now we have 1, 2, 3, 4, 5, 6. But now, as you can see, they're off the stage. They don't quite, they're not quite lined up. So let's play around with this real quick. Let's move the y first. Okay, so we'll set red square dot y equal to, let's do red square, oops, I don't know why I'm just copying that, dot height divided by 2.0, so that way we get actual decimals. So we're going to set red square dot y equal to red square dot height divided by 2.0. So because our registration point is in the center, we need to move it down by half its height so that the full thing is actually in our stage. So that's all I'm doing right now. So we should get the same thing we did last time, but just shift it down so that the entire red square is on the stage. Awesome. Now we need to also move this thing over by half of its width. So since we are multiplying, let's just throw this in parentheses real quick. And we can copy this line here. Let's throw some parentheses here and a plus sign. And what we're going to do is just we're going to move it over by whatever the height is. It's a square, so we could use height, but just in case we change anything, we'll say width. So we're going to move it over to the right by whatever the width is. So that's just shifting everything. And then we're going to add I times whatever the width is. So what this should give us is lined up how many squares can fit in the stage. So blah, 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 blah. And you can see here, this last one wouldn't quite fit, so we don't actually put it there. But what if we wanted to space things out very nicely so that it covers the entire stage with maybe a little bit of border space in between? Well, what we can do is in our actions, we need to get how much extra space there was. And the way we can get how much extra space there was is, well, we can take test to get 6 and then subtract test from what that number was before we floored it. So what we can say is var extra space, and it'll be a number because it'll be probably a decimal. Actually, it's guaranteed to be a decimal. And we'll set it equal to whatever test is, okay? But we actually need to subtract test from something else. So we need to subtract test from stage width divided by red square dot width. So if we copy this and paste this here with the parentheses that say minus test, this should give us the decimal that is remaining. In this case, for me, it should be 0.875. All right. So now what we need to do is adjust the spacing in between each object. So right now we were saying I times red square dot width. Well, we need to say I times red square dot width plus some version of the extra spacing. So it gets a little messy here, so let's create another variable, okay? And we'll call it var spacing. It'll be a number because it'll probably be a decimal. And we can set this to equal red square dot width, so this here, red square dot width plus we need to add on the extra space, right? But we don't need to add on the extra space, the entire extra space. We need to add on the extra space depending on how many objects we had. So in this case, the number of objects we have are test. We stored that in test, so we have 6 for me. So we're going to take the width, so the full width of the red square, plus whatever test is divided by, I'm sorry, not test. We're going to say whatever extra space is. So we're going to take all that extra space and we're going to divide it by test. I'm going to throw this in parentheses because it makes it a little bit more easier for me to understand. And so what we're going to do is we're going to take red square dot width and add on however much extra space was evenly divided by each one. So we're going to get rid of red square dot width and replace it with spacing. And I accidentally forgot to add or delete this parenthesis here, so get that parenthesis in there too. So just be I times spacing, and then we can see what that does. And this isn't quite what we need, because what we're doing is we're spacing it out, but we're not actually getting the extra space. We're just getting the percentage of our full width of a red square, essentially. So what I mean by that is spacing is only getting whatever the width is. So in my case, it was 80 plus 0.875 divided by 6. So it doesn't need to be that. It needs to be whatever that fraction ends up being times the width of the red square, because it is a fraction of the width of the red square. So this is why it gets complicated, and maybe I might lose you here. But if we multiply this, so let's throw some extra parentheses around this whole thing here. If we multiply whatever we get out of this by the width of red square, we'll take that fraction and make it actually be the proper value. So we're just making that fraction bigger, so it should be the actual value to make everything line up correctly. So now, cross your fingers, everything's evenly spaced, and you can see that right here we have a gap at the end but not at the beginning. So we need to do one more thing. We need to offset this by half of spacing. So yes, this is complicated, but let's do this so that we get nice clean edges. All right, so besides just adding red square dot width divided by 2 so that it lines up, we also want to add spacing divided by 2. So plus, and let's put some parentheses in here, spacing divided by 2.0 because I want to make sure it's decimal. So now that we have this, we're just pushing everything over to the right a little bit more, and poop. The reason why that doesn't work is because we actually don't need the full spacing. So the full spacing is from here to all the way about over here, and what we need is just half of this little gap here. So what's the gap? Let's maybe make this a little more easy to read. The gap in between our lovely little objects here is actually just this part right here. So let's create another variable above this. We'll say var gap, and we'll make it a number, equals this here. So we can just actually cut this whole thing out and replace it with the word gap. And we're going to paste this over here. And now we don't need these parentheses at the beginning and the end because there's no fancy schmancy math. And we can do that just like that. So now we have the red square width plus gap to get spacing. And instead of spacing here, this needs to be gap. So the math, like I said, might be a little bit hard to follow, but it all makes sense. So here we go. We have a gap. And notice how now at the ends, we have exactly half of whatever the gap is because we shifted it over to the right half of the gap with this right here. But why stop there? Let's make a full grid. And let's also handle the why. This is where things will start to get a little bit complicated. We need to make a for loop inside of a for loop. So we'll use I to handle the X, and we'll use another variable to represent the Y. In this case, we can use J. So the logic behind this whole thing is still going to be the same, but we need some other variables and we need to clean some stuff up. So let's change some variables. Instead of test, we want to call it something else. So let's do a control F so that we can find and replace things. We're going to replace test with what it actually is. Well, it's how many times we fit in stage, right? The stage width. So we'll call this, instead of test, we'll replace it with times fit in width, okay? And that's kind of a big variable, but we'll just click replace all. So now instead of test, we have times fit in width, times fit in width, and times fit in width, okay? So extra space, we want to replace this as well. So we'll press Control F, and instead of extra space, so extra space, we want to replace it with extra width, okay? So replace all, there we go. And then gap, well, we only want the X's gap, I guess, and same with X's spacing. So let's take gap, press Control H, or sorry, not H, F. We'll change gap and change it to gap X, so we know that's for the X. And then we'll also change spacing, oops, let's just say spacing with spacing X. So replace all. So we just changed the names of our variables, and to make sure this still works, run it one more time, make sure that these things are all lined up. Beautiful. So now here we get interesting. All right, we also need to do all of this stuff for the height. Okay, so let's copy these two lines here, paste them a couple of lines below, and we will call this, let's do this really quick. We can fit RS width in stage width, so we're just going to change that comment up a bit here. To do what I'm doing here, if you have the end, press Shift and the Home key. It'll select all of it, and Control C to copy. And we'll move this down here. And instead of how many times we can fit RS width, we'll say how many times can we fit RS height into stage height. Okay, and then we need to change these variables here as well. So instead of times fit in width, we'll say times fit in height. Okay, instead of stage.stage width, we want this to be stage.stage height. Instead of red square dot width, we want red square dot height. Okay, so that's that line. Instead of extra width, we want extra height. Instead of stage.stage width, we want stage.stage height. And if you're looking at this here, you're thinking maybe we could just do a control F. We could, but I'm going to do it this way. And make sure you get everything. So times fit in width, times fit in height. And instead of gap X, we want gap Y. Instead of extra width, we want height. So we're just changing everything from width to height. Height there. Instead of width, we want height. Instead of spacing X, we want spacing Y. Instead of that, we want height. And instead of gap X, we want Y. So make sure that you changed all of these to be related to height and Y, and that we still have one for our X's. And then inside of here, we need to change one other, we need to add another for loop. So let's create another incrementer. I like to either use J, the next letter in the alphabet after I, or you can use I2. I'm going to go with I2 for this one. So we'll say var I2, and in case we ever reuse it, it'll be an integer. Okay. And right inside of our for loop, we're doing a for loop inside of a for loop. And we're going to say var or for I2 equals 0. Okay. As long as I2 is less than times fit in height, because we're doing height in this instance, semicolon I2 plus plus, put a parenthesis to close that whole thing, and then put your curly brackets. And now, how is this going to operate? I'll walk this through logically. You can trace these things out and play around with for loops inside of for loops if you like, but anything dealing with a grid is usually going to use some kind of for loop like this. So we're going to go through the width, right? So let's say this is the X. We're going to go through 0, meaning it is the first column. And actually, I could probably draw this out. So we're going to go through the first column first. So we're going to start here, right? At the very beginning. Okay? And then we're going to go through all the Y's because the 4 is in here. So we're going to start here, loop through Y however many times we need to, and then go to the next X. So the order that this is going to go in is it's going to start here, go here, here, oops, I'm not clicking here, here, so on and so forth, and then start again here and go like that. So it's going from top to bottom and then left to right. Okay? So I'm going to erase that there. So let's actually throw this in. So this part that we have here, we want to throw this whole thing inside of this for loop here. So if it's not tabbed out right, just select it all, hit tab to move it over one. Select it and press shift tab. Oops, I guess one line you can't, but if you had multiple lines, it would be shift and tab. So now we're adding red square equals new rs. We're setting the X to whatever the width should be. And we also need to do this for the height. So let's just copy this line here and paste it on the Y and change this to height, this to gap Y, this to spacing X, or sorry, spacing Y. And it should be exactly the same except with height instead. And now what we should get is a perfect grid, I guess, of, what did we mess up? Forgot one thing. For the height, we're using I2. So instead of I here on Y, it should be I2. And you see how you can start to get some pretty cool effects here. But if we run this, ta-da! A beautiful grid of nice little borders here, and voila. So the only thing that's a little yuck about this, I guess, is that these lines aren't even, and there's other ways to get the padding even. You would just have to kind of deal with it in another way, and I'm not going to walk you through that. But what we can do is change the size of our stage to, let's say, 550 by 550. So if you click on your stage under properties, you should say 550 by 400, change that to 550 by 550. Now our code, the cool thing about this is it'll fix and fit any size stage we want. So we say 550 by 550. Now our borders are even because we're putting squares into squares, but you can see it's added more, it's filled in the entire thing. So let's roll with this. your monitors might be different sizes than mine. I don't know quite your resolutions, but let's go with something crazy like 800 by 800. So my stage is pretty big. I haven't changed a single line of code, but because of the way we have this set up, we can create a full grid, any size stage we want, and there we go. I believe mine just actually got bigger for some reason. This should look nicer. There we go. If your stage doesn't come out right, run it again. Sometimes the stage size doesn't create initially correctly. But now we have this. There we go. We got nice borders. It fills for any size stage you want. And this is a cool way where you can set up a grid for a game. So now, if we even put code inside of a thing, you know what? Let's take this one step further just so we can be cool. Let's put some code inside of our red square, right? So let's go inside red square in the library, and I'm finishing this video up really quick, but just to give you some idea of how this could be used. We could send this to another frame. We can do something along those lines, but what we want to do is let's just remove this from the stage whenever we get clicked. Okay, so we need an internal movie clip for this to actually, do we? No, we don't. Okay, so let's just make some actions inside of our red square. New layer, double click, there we go. Actions. And then inside of the red square, we're going to make it fancy. So what do we want to do? First thing we want to do is add an event listener for a mouse click. So we'll say mouse event dot click. And then we want to give a function name. So let's just say on click. That's not taken. Okay, cool. So on click, we want to do this. What do we want to do? Well, it's a function. The name is on click. Oh, not clock, click. What are we taking in? We're taking in a mouse event. So I'm just using E to represent the variable that will store that. I press tab or space or whatever, so it ends up importing it. It's fine if you import it. You don't have to. And we're not returning anything, so let's say void. And what we want to do is, when we click, we want to get rid of this event listener here. So let's copy this, paste it here, and say remove event listener. So that way we get rid of it. And then we want to actually remove this whole thing from our stage, right? So what we can do is say parent, so that we get our main timeline or our main stage, dot remove child. We need to get parent first because that's where this movie clip will be contained, because we're adding it to the parent or whatever the stage, main timeline, or even if we put it somewhere else. Remove child, we want to remove this. This will be whatever we are. So we're going to remove this from the parent when we click on it. So now that that's built into each one of those little red squares, we should have a perfect grid on whatever size stage we have, and we click, it can go away. So you can spell out, I don't know, what do we want to spell out? D for Mr. Davis. So there we go. Every time you click, it goes away. And you can make your little red square smaller. You can say instead of on click on mouse over that they disappear. You can do a lot of cool things with this. And there you go, you have a grid set up. And the math is a little complicated, but you can maybe take a look at it, figure it out, or you can just play with it. So this is the code inside of the red square. So we're just adding the event listener for click and then removing it and this object from the parent. And then the main code, let's go over a real quick review. We learned how to do break. So whenever we want to exit a for loop, we just say break and it completely stops. If we say continue, it just skips on to the next part of the for loop. And then here, what are we doing? Well, here we're getting how many times we can fit in the width. We're seeing how much extra space we have left. So that little extra gap to the right, if you remember that. Then we're getting how big the gap in between each thing should be. So the gap should be, where is that? The extra width divided by times fit in width. So whatever that extra little space is to the right of everything, how wide is it? Split that up by however many little objects we have that can fit, and then multiply it by the red square's width because it needs to actually be, it was actually a ratio of the width from that. So that's why we're doing that. And then spacing X, how much space do we want in between each little little square is red square dot width plus whatever the gap is. So whatever our red square size is plus that additional gap. So this is doing the same thing except for height. And then we have our for loop inside of a for loop that runs from top to bottom, left to right. Inside here, we're creating a new red square. We are setting the x equal to, well, we're starting it off at halfway because our registration point was in the center. Then we're adding half of the gap, so that way our things are shifted a little to the right, so we have even outer gap, I guess, around the edges. And then we're adding whatever I is plus our spacing. So when we start, I is going to be 0. The spacing will be 0, so we'll just start at this spot. When we get to 1, we'll add whatever I times the spacing is, so just whatever spacing is, and then 2, and that's how that shifts that over. And then here we're just doing the same thing with y, except with I2, because I2 is what we have set up for y, and we just add it to the stage, and that's it. So maybe the math's a little complicated. If you break it down, if you look at it, throw some more comments in there if you don't understand what's going on. This will be very useful if you want to make any kind of like puzzle game or tile game or matching game. And I just really wanted to go in depth for how much you can do with for loops. So you could put 3 for loops in a row. You could actually simulate something that's like a Rubik's Cube. So we'd have the X, the Y, and maybe the Z. And Flash is in 2D for the most part. You can do 3D, but if you want to make a 3D cube, you just add the 3rd dimension. So think of this as 1 dimension. This is the 2nd dimension. And then you could keep going as deep as you wanted. So I'm going to stop it there. This video is kind of long. The main thing I want you to take away is that you can put for loops inside of for loops, and that continue and break, how they work. All right? Beautiful. Have a nice day. You're gorgeous.